Hey guys, this is Sintana graduating in Sri Venkateshwara College of Engineering. Today we're gonna discuss about the topic of test of significance of means of two samples. Test of significance of means of two samples. In that we're gonna discuss about the introduction of significance testing. Significance testing is a statistical method to determine there is enough evidence to reject the null hypothesis. It's a crucial in research for making inferences about population parameters based on a sample data. This presentation focuses on testing the means of two samples. Importance of sample size. The sample of the size can greatly influence the reliability of the results. Small samples may not fully represent the population, leading to the potential biases. Understanding how to test small samples is essential to accurate statistical analysis. Null and alternative hypothesis. The null hypothesis typically states that there is no difference between the means of two groups. An alternative hypothesis suggests that the significance difference exists between the two group means. Clearly defining this hypothesis is critical for conducting significance test. Types of test of means. The t-test is commonly used comparing the means of two small samples. Different versions of t-test exist depending upon whether the sample is independent or a pair. This choice of a test affects how the interrupt of the results is analyzed. Independent sample t-test. The independent sample t-test is used when two samples from a different groups. It's assumed that the two groups are approximately normally distributed. This test evaluates whether the means of the two groups are statistically different. Paired sample t-test. The paired sample t-test is applied when the samples are related or matched. This could occur in before and after the studies or when the subjects are matched by certain characteristics. The focus on the difference between paired and observation is there is a difference between the two groups and difference between the 2 points. Assumption of t-test. The both types of t-test has sample assumptions that must be met in a valid results. Key assumption includes normality, independence and homogeneity of the variances. Violation of these assumptions can lead to the inaccurate conclusions. Normal assumption means that the distribution of the sample mean should be approximately normal. This can be checked using graphical methods like UQ plots and statistical tests like Shapiro-Wilk test. If the sample size is small, normality and particularly importance is validate. Homogeneity and variances means that the variance of two small groups should be approximately equal. This can be assessed using the Levin's test or the t-test for equality of variances. In this assumption, the validated or violated adjustments can be necessary. Conducting a t-test, first calculate the sample means of standard deviation between the two groups. Next, determine the t-statistical using the appropriate formula for the type of t-test. Finally, compare the t-statistical for the critical value from the t-distribution table. Interrupting t-test result. The result of the t-test will lead to p-value indicating the probability of observing the data. The low p-value, typically less than 0.05, suggests that there is no significant evidence against the full null hypothesis. Conversely, a high p-value indicates insufficient evidence to reject all the null hypotheses. Reporting results. Results should be reported clearly starting from the means of standard deviation, statistical and p-value. It's also important to mention the confidence intervals for the more comprehensive understanding. Transparency in reporting enhance the creativity and credibility for the research finding. Practical application. The t-test is widely used in various fields including psychology, medicine and social science. This helps research make a data-driven decision based on a statistical evidence. Understanding how to conduct an imperative t-test is essential for effective research. Limitations for t-test. The t-test have limitation particularly when small samples are exclusively small. They are sensitive to outliers which show the result significantly. Research should consider these limitations when drawing conclusion from t-test results. Alternative test for small sample size. When assumptions for t-test are not met, alternative test may be more appropriate. Non-parametric test like Man witness U test can be used for independent samples. These tests do not assume normality, can be more robust in certain situations. Software for t-test. The statistical software packages like SPS, R and Python may conduct t-test straightforward. These tools provide built-in functions to streamline calculation and interruptions. Utilizing software can reduce manual errors and enhancing efficiency in data analysis. Common mistakes to avoid is ignoring the assumption of t-test, leading to invalid results. Another frequent error is misinterpreting p-values, leading to incorrect conclusions. Ensuring clarity in null hypothesis formulations is also critical to avoid the conclusions. As a case study example, we'll consider a study comparing the effectiveness of the two teaching methods in test scores. Researchers should use an independent sample t-test to analyze a score from two separate classes. Results would inform discussion about which teaching method to adopt based on the statistical evidence. Thank you.